Students, let's try to understand wave nature of electromagnetic radiation. We are going for only for the wave nature, student. Okay. James Maxwell, okay, in 1870 was the first to give the comprehensive explanation about the interaction between the charged bodies and the behavior of electrical and magnetic field. So if any charged bodies is there, it is capable to produce the electric and magnetic field. On the microscopic level, he suggested that when an electrically charged particle move under the acceleration, alternating, alternating electric and magnetic field are produced and transmitted. The, these fields are transmitted in form of the wave called electromagnetic wave or electromagnetic radiation. So, dear student, if you go through the slides and trying to understand, you will find the very easy and clear cut statement here. That is, every charged body here, see, interaction between the charged bodies, charged bodies and the behavior of electric and magnetic field. So, if the charged bodies is there, student, they are saying he suggested when electrically charged particle move under acceleration. So suppose this electron is there, if you try to understand, here suppose the new positive charge nucleus and here electron is revolving around the nucleus. So what it is going to do, student, what they are saying, alternating electric and magnetic field are produced and transmitted. So from this what will happen, student, here that is alternating electric and magnetic field are being produced. Okay, so suppose it is the electric field, so it is going to be a magnetic field, this is going to be produced. Now light is the form of radiation known from the early days, and a speculation about its nature date back to ancient times. In earlier days, light was supposed to be made of particles, corpuscles. Newton's corpuscle theory could successfully explain the phenomena of and reflection, but failed to explain the phenomena of diffraction and interference. Therefore, corpuscular theory was discarded and was replaced by Maxwell wave theory of light. According to this theory, light transmitted in the form of electromagnetic wave. These waves are associated with oscillating charge and magnetic field. The important properties of electromagnetic waves are listed below. So you might have understood, student, that is light is the form of radiation that is known early days, and speculation about its nature date back in ancient time. In early days, light supposed to be made up of the particles, that is corpuscles. Newton corpuscular theory could successfully explain the phenomena of refraction and reflection, but failed to explain the phenomena of the diffraction and interference. Therefore, corpuscular theory was discarded and was replaced by Maximal wave theory of light. According to this theory, see the statement here is, according to this theory, light is transmitted in the form of electromagnetic wave. So whatever the light is coming, that is in the form of electromagnetic wave. These waves are associated with oscillating electric and magnetic field. And what are the important point here? The oscillating electric and magnetic field produced by oscillating charged particle are perpendicular to each other. So you can see these waves are producing are the perpendicular. Here you can see these are the perpendicular. Both are perpendicular to the direction of the propagation of the wave, and simplified nature of the electromagnetic wave is shown. So both are the perpendicular. The electric and magnetic field component of an electric wave, these components have the same wavelength, frequency, speed, amplitude, but they vibrate in mutually perpendicular plane. Unlike sound wave or the water wave, electromagnetic wave do not require a medium and can move in vacuum. Different kind of units are used to characterize electromagnetic wave. The first is wavelength. It is defined as the distance between two neighboring crest or trough of the wave, showing in figure 4.10. So let us see the 4.1. This is the trough. So this is the wavelength, or this is the crest, that is wavelength. Wavelength is represented by Greek letter lambda and generally measured in the angstrom or the nanometers. Frequency. The number of wave which passes through a particular point in 1 second is defined as frequency or the wave function. It is represented by Greek letter nu. The SI unit frequency mu hertz, nu hertz, that is 1 CPS is equal to 1 hertz. This is what velocity. The distance traveled by the wave in 1 second is called velocity of the wave. It is represented by the letter E, the frequency V, wavelength lambda, and velocity of light c related by the equation c is equal to nu lambda. In vacuum, all type of electromagnetic radiation, regardless of wavelength, travel all the same speed, that is 3 into 10 power 8 meter per second is called the speed of light. Now go for the wave number. It may be defined as the number of wavelength per unit length. It is equal to inverse of the wavelength. It is denoted by nu bar. Its unit is the reciprocal of the wavelength unit, that is meter inverse. So this is amplitude. It is the height of the crest or the depth of the trough of wave. It is denoted by letter A. Amplitude of determine the intensity of the radiation. So this is all about the electromagnetic wave, student. Thank you so much.